Where is math? It's in motion, in space, in patterns, in the world around us. Nearly 900 years ago, the Indian mathematician Bhāskara II approached mathematics in much of the same way. In his book, Līlāvatī, mathematics became playful, poetic problems about swans, bees, lotus flowers, and everyday life. But today, students often meet mathematics here first, as symbols and formulas they're expected to understand before they've experienced what they mean. So what if we reverse that? That's the idea behind Lilavati, an iOS app where mathematical concepts become interactive games and simulations. Instead of putting math questions inside games, I wanted the gameplay itself to reveal the mathematics. I picked out 3 of my favorite levels from the app, but in my build submission, I've included and highlighted not only the levels I've built since July 13th, but all of the 100+ levels in the app I've created using Codex. So let's see how they work. Cymatics is a wonderful way to show the relationship between pattern design and sound frequency. When we learn about sine and cosine waveforms, this is a perfect example of that. I wanted the user to get an audio-visual feedback of what that looks, feels, and sounds like, with the underlying math concept being reinforced by interacting with the simulation. So we are taking what a student can recognize, geometric patterns and sounds, and then revealing the mathematical concept underneath it. There are infographics at the end of every level to further illustrate the math behind a game or simulation that the user can explore by themselves or with guided instruction. Lastly, we have one of my favorite levels. I was inspired by a game of tic-tac-toe with my friends, but it felt way too easy, so why not make it 3D? Then I realized this was reinforcing a math concept I learned in pre-calculus and geometry, 3D coordinates. So a user can either select a block, or they can select a coordinate that selects the block for them. Gamifying a class lesson like this allows the user to see the concept play out visually and in an engaging manner. Perhaps the reviewer team can have some friendly competition with this one, but please feel free to explore any of the other levels I've included. I also want to share with you my background in relation to this project. My own path went from technology consulting to teaching chess to pursuing my master's in mathematics education. Līlāvatī became the intersection of all those experiences put together. I frequently see a gap between teachers and technology. Many high school teachers don't come from a STEM corporate background, so I wanted to combine my data science and programming skills with teacher pedagogy and curriculum. So getting more into the process of how I made this, Līlāvatī became a passion project, and during OpenAI Build week, I used GPT 5.6 with Codex to rapidly expand it with new mathematical experiences. I could describe the mathematical concept, the gameplay mechanics, and the visual behavior much better than I imagined, then work with Codex to implement, debug, and refine it directly in Xcode. Because every mathematical concept requires different mechanics, Codex dramatically shortened the distance between an educational idea and a working experience. What I've learned is that AI can give educators the ability to become creators of the learning experiences that they imagine. My next step is bringing Līlāvatī into real classrooms and studying whether these experiences can help students build stronger conceptual connections to mathematics. Nearly 900 years later since Bhāskara, the tools have changed. With GPT 5.6, I was able to accomplish my vision of what math should look like in the 21st century. I still believe that mathematics can begin with curiosity, discovery, and play. Thank you for your time.